Question 1 is giving us this equation, x cubed plus 2y squared equals 6, and it wants us to find the derivative dy dx. It asks us to use this process called implicit differentiation. We have to use implicit differentiation whenever we've got x's and y's kind of mixing together within our problem. Normally we're used to seeing just the y on one side and a bunch of x's on the other. But once we start having x's and y's mixing together within our problem, from there we need to learn this new process which is called implicit differentiation. So how this process works is I take my equation, I wrap it in a set of parentheses, and I'm going to dx this whole equation. I'm going to take the derivative with respect to x is what that means. So what happens here is we're going to take the derivative like we always would, but every time we take a derivative, we're going to get some extra shit is what I always say. So what that extra shit's going to look like is that we're going to have d and then envision there being this box on top there, and we're going to fill that box in with whatever the letter is we took the derivative of and put that always over this dx. So starting with our x cubed, the derivative of x cubed would have been 3x squared. I took the derivative of an x, so I get a dx over dx. Every time I take a derivative, I get extra shit. Then I move on to my 2y squared. I'd bring that 2 down. I end up with 4y. I took the derivative of a y, so this time I fill my little box in with a dy dx. And then the derivative of a constant is always just 0. So the derivative of 6 is just going to be 0. From there, I go ahead and do a cleanup step. So I work my way through my problem. I've got a 3x squared, and then dx divided by dx, that's like having a 5 divided by a 5. Those things just cancel each other out and are really a 1 sitting there. So I don't really need that. So then the second piece, I get 4y and then dy dx. I only wrote those boxes in there just to show you how I am mentally filling them in. You don't really need them as you do the work. And then all of that is equal to 0. This problem wants us to go find dy dx, so the rest of this problem is really just an algebra problem where we're trying to get dy dx by itself on one side of the equals. So to do that, we'll start moving everything away from it. I'll start by moving this 3x squared term. So minus 3x squared, whatever I do to one side I have to do to the other. 3x squared minus 3x squared is going to cancel out. That'll leave me with 4y dy dx equals negative 3x squared. Again, we're trying to get dy dx by itself, so these two pieces are being multiplied. So to get rid of that, to undo that multiplication, I'm just going to divide both sides by 4y. So the 4y's will cancel, and that's going to leave me with dy dx equals negative 3x squared over 4y. So that's what dy dx equals. That's what my derivative equals. And that is my final answer. And we can see that that answer sits here at answer C.